In this lecture, we shall discuss some advanced level problems on friction. When I say problems on friction, it means problems on application of Newton's laws, assuming realistically that the surfaces are not smooth and therefore frictional forces, either static or kinetic, are coming in the picture in addition to the other forces as well. There will be a series of lectures on the same topic, therefore I number it as 1. And as usual, we shall divide the problems further into 3 categories using 1 dot for difficulty level 1, 2 dots for difficulty level 2, and 3 dots for difficulty level 3. So let us go for the first problem in advanced level on the topic of friction. Once we have come so far, let's look at the question once again. They're looking for the minimum horizontal force F needed so that blocks 1 and 2 remain stationary with respect to block number 3. So looking for a limiting case in which we find minimum horizontal force. And under this limiting situation, these static frictional forces Fs between block 1 and block 3 and Fs dash between block 2 and block 3 reach their limiting value, that is Fs max. So we shall go for those limiting values, apply the law of friction to write down limiting friction is equal to mu times normal force, change the equations and manipulate them to get the minimum acceleration for the system, and that will be the way of approaching the problem. Let me rearrange my space a little bit. I want to get some space and keep writing on this page only. So let me write it here, since we are looking for the limiting condition in which the force to be applied has its minimum value. So under this limiting condition, the frictional forces, first of all, between block 1 and block 3, that force is called Fs and corresponding normal force was N. So Fs acting on block 1 becomes equal to Fs max, the force of limiting friction, by law of friction, that is equal to frictional coefficient mu s into the normal force, that is mu s into N. But then looking at equation number 2, you can see that is giving me that N is equal to m1 into g, right? So Fs has this limiting value of mu s into m1 into g. Similarly, for the frictional force acting on block number 2, that force Fs dash in limiting situation that attains the maximum possible value, that is limiting friction, which is frictional coefficient multiplied by the corresponding normal force, that is N dash, and equation number 3 is giving me N dash is equal to m2 into a. Therefore, Fs dash has a maximum value of mu s into m2 into a. So see here, we have got the corresponding limiting frictions acting on blocks 1 and 2 using equation number 2 and 3. We have got it here. We'll be putting these values now in equation number 1 and 4. So equation number 1 is this and equation number 4 is this, and let me write it here that equation number 1 is now becoming T minus, well, the value of Fs now, Fs max, I'm putting it T minus mu s into m1g, that is equal to m1 into a. And similarly, equation number 4, that is now becoming, you can see here, that is T plus Fs dash, max value has been found just now to be mu s into m2 into a minus m2g is equal to 0. Let me subtract one equation from the other. I go for the subtraction, just see carefully, and if we subtract equation number 1 minus equation number 4, let me, this minus, this becomes also minus, this becomes plus, and that is this T and minus T cancelling out. We have got, as you can corroborate yourself, this is m2g minus mu s into m1g. Let me keep it on the left hand side. On the right hand side we have got M1A, and if I take this term on the right, this is now becoming plus mu s into M2 into A. We are looking for A here, and therefore the value of A, that is the minimum acceleration required to be given to the system so that blocks 1 and 2 do not have motion with respect to the block number 3. So I'm calling it minimum value of A. This, as you can see, is coming out to be M2 minus mu s into M1. Let me keep inside a bracket into G outside, divided by, this is in the numerator, and then we have got in denominator that you can see this is M1 plus mu s into M2. So this is the expression for minimum acceleration for the system in symbolic form, M2 minus mu s into M1 whole thing into G divided by M1 plus mu s into M2. And if we have the values, let me put them, and we are getting here by putting the values, minimum acceleration for this 3-block system, that is coming out to be, well, M2, you can look at the data given above, I'm writing from there only, that is 1.00 kg minus mu s 0.25 into M1 was 2.00 kg. This thing into the value of G free fall acceleration, let me take it to be 9.80 meter per second square, whole thing divided by M1, that is 2 kg plus mu s 0.25 into M2, that is 1.00 kg. Complete the calculation and show that the value of A min is coming about 2.18 meter per second square in 3 significant figures.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.